I missed that one before. Hey, there it goes. Hey, welcome to Coffee Compiler Club. We're here today to talk about how to spell yes and no, or anything to do with language design and compilers and compiler runtimes. I think we had yay and nay and 0 and 1 and true and false have different counts of letters. And Simon has a presentation. So we're going to answer whatever quick questions. And then I think, Simon, are you going to be ready to go? I think we have a quorum here. Yep, okay. Got done with my piece. I think Adrian and Simon, you sorted it out and you're ready to go? Okay, take it away, Simon.
All right, let's try this. No idea whether the full screen works or not. Is this working?
Yeah.
I have no idea what I'm showing right
As
now.
the minimum amount of mistakes you should have learned from before.
Okay,
That
great.
and your bank statement is also up on the screen.
Oh well, then there's nothing to risk.
There's nothing there. It doesn't matter.
So the purpose of the talk that I'm working on, that is also not finished, and I'm only showing the current work in progress, and I hope you have some thoughts on how to improve it, is which kind of mistakes I probably don't want to see in future languages because they have been made too often and too long, and it's getting boring. And the idea of the talk is basically convincing people to not make the same mistakes over and over again. And the title is basically the minimal amount of mistakes you should have learned from before designing your language. And how do I? So the plan for today is avoiding past mistakes. You ain't gonna need it. Doing more with less. These are like the 3 tentative chapters where I try to put various topics into, and all the things I mention are low-hanging fruits that should apply to many languages or most languages even. And some of the points might be considered just a syntax discussion, and I think that's also perfectly fine. I mean, often it's often said, well, it's just syntax. Syntax doesn't matter, and I heavily disagree on that. That's why I'm not trying to avoid the syntax discussion in the upcoming slides, but I rather embrace it. Right? So first of all, what is a presentation about? People are building languages for many different reasons, and in many cases, the language itself is not the focus, but it's just a tool that enables the actual goal that the person wants to achieve. And with that territory, often it happens that the person uses whatever he or she knows. The person often knows where he or she wants to end up as a goal, but there is very little research done on the parts that are not the focus of this new language design endeavor. And that means that many existing design mistakes will be copied. And I'll argue that at least some of them are easily avoidable. So what does it actually mean, building language? And it means a lot of things. It starts with language design, where you can spend like 40 years on it. Means practical things like defining grammars, lexing and parsing, abstract syntax design, type system design, optimizations of all kinds. You have to think about a module system and how it factors into separate compilation. Concurrency is another topic where you can spend 40 years on how the runtime should work and interact with the host system, how memory should be managed, how the calling convention should look like, how linking and tooling and technical writing and website design and user support and security and community management should be handled. And if you take all of this together and say, well, with an average human lifespan, 24-hour days and normal sleeping habits, you have
Wait, are you saying that we have normal socializing habits?
hopefully, right? So I mean, it's like you have the chance of having maybe 3 or 4 disciplines where you become a master at, and everything else is basically best effort. And even if you say, well, I don't have to be an expert at everything, I'll just find other people that are experts at their respective disciplines. We go back, then one of your mastery you have chosen to invest is basically sunk into this community management thing already. So you have like 2 to 3 actual technical masteries left. And all of that means you have to basically pick and choose what you're good at. And this talk is at least trying to get you a head start on avoiding some of the mistakes that might be costly later on. Principles. If you're creating a language, what kind of principles apply? So one popular thing is, of course, familiarity, where the fear is if my language doesn't look like C or Java or JavaScript or whatever is currently popular, nobody will use it. And the reality is, though, that nobody is going to use your language with like 99.9% chance. So stop worrying about it. Another term that comes up often, and that's worthwhile defining, is simplicity. And it's not the same as familiarity, but you can consider that familiarity is designing for existing users or users of the past, people that are already familiar with older languages. And simplicity is designing for future users, saying, well, there are people that come with a fresh slate that don't have like 20 years of legacy knowledge about weird special cases and quirks and whatever coming from other languages, but people who just want to learn a language, and the simpler it is, the more they benefit from it. And simplicity takes an active effort to achieve, and it often means leaving things out and not putting things in. I usually say languages are rarely improved by adding features, and I think that's one of my key points here. Yeah, favor simplicity or familiarity. Complexity is also a term that's getting used in terms of language design. And often there is like a budget associated with it, saying, well, you only can spend so much complexity on your language, and then people will just have trouble understanding the language or code written in it. And one thing to keep in mind is that familiarity usually increases complexity, because familiarity is not the same as simplicity. And that's basically a concern where you have to actively, if you want to fight against complexity, you have to keep you can't do everything just because it's familiar. And if you spend all your complexity budget on the basics, you basically don't have any budget left for investing in the interesting parts, which are probably the reason you built your language in the first place. And, yeah.
Simon, I've heard it called the weirdness budget, which is
Yeah, the strangeness budget, yeah.
Yeah, it's a distance from familiarity. It's not complexity. It's just the distance from being familiar.
Yeah,
This goes to
that's
the familiar versus simple.
exactly. That's why I'm not using strangeness weirdness budget, because I don't think it's a very good term. It's just strangeness budget is basically saying, well, always do the familiar case and then you're good. And I think that's just silly.
I have a question. Is it fine to ask questions now or
Yeah,
later?
sure.
Namely, I was wondering, with complexity, do you mean complexity from the perspective of a user, or complexity from the perspective of someone who implements the compiler and the language?
I think both. It's usually not easy to let's say to distinguish between they are linked. Let's call it like this. I think this slide is pretty nice. I think so complexity for the user is basically if you have a language feature and it's so complicated that you can't make it easy to use for your user, the complexity from the language design or compiler construction perspective leaks into the user space. So I wouldn't even distinguish between those concerns. I mean, a good feature is simple to specify, simple to implement, and simple to use. And if you fail in one part, you're usually also failing in the other two parts. And
so how would you evaluate something like garbage collection on that dimension that often has very little overhead in the developer's mind and almost no syntax or actually no syntax, but is a lot to implement?
I would disagree with no overhead in users' minds. It depends what your user is. The developer, nah, no overhead, right? For the production maintenance guy, the guy who's trying to run the thing on your box in a production system, GC is like half their freaking workload because they have to keep tweaking flags and GC logging and changing GC algos and whatever. I mean, I talk to so many people who like GC eats up their brains trying to get it to run in production. Great for the dev.
Yeah, I mean, it's certainly a very good point. I think garbage collection has this advantage that it's 1 degree further removed from the user compared to basic language design decisions of whether your language has like operator overloading or whatever. And I mean, maybe garbage collection is a good counterpoint of where you can say that you can invest a lot of complexity into the implementation details without leaking it into the user space, or without leaking it to the users of your language. Maybe that's also because there's no real interface exposed to the user for the garbage collector. So the implementation is kind of invisible to the user. But yeah, I mean, it's a good point that warrants some additional thought, I think.
Let's roll on here.
Yeah, so I have this slightly functionality, and the thing Adrian mentioned with complexity is that basically every step you take from implementation to documentation to IDE support to maintenance to debuggability it's an additional increase in complexity. So maybe it takes 1x effort to implement, and then it takes 2x effort to document the thing you just implemented, and then it takes 3x effort to implement the IDE support for that feature, and 4x over the lifetime of this feature to have it maintained, and so on. And these costs scale, and that's one of the reasons why I think keeping things as simple as possible makes a lot of sense, because the features are really expensive. Sorry.
I have a question to Simon. So what are your view about these things? Are there modules so you can advance from one thing to the other, or you can somehow advance them all at once? So which would you prefer? So to first invest in the implementation and then to a modular to advance like a module by module, or you have to do all the things at once?
I mean, that largely depends on what skill set you have in your language design project, and what's fun and what's not. It's like if you have a single person project, just do whatever you want, because if you work on things you don't like, you run out of motivation and out of happiness, and that's a guarantee to kill your language, because you're a single person, and if you're burned out, the language is dead.
One of the
Yeah.
obvious things is to go for the implementation first, so to see how things pan out.
Yeah.
But beyond that,
Yeah, I absolutely agree. I think yeah, I think I agree with you. I mean, you have to work on the implementation. I mean, perhaps you can say, yeah, well, specification comes first, and the spec is technically documentation and not implementation. But I think it's just the talking semantics. Like, yeah, sure, you have to implement it, and after that, it's basically best effort, considering the people you have available to your project and your resources, and that's basically that will determine what's happening in your language and what don't.
okay.
So the main thing, if you don't want to keep your language on a single digit of users, is adoption. And if you pretty much look at all the existing languages in computing history, it's pretty much being at the right place at the right time. That's it. There is not much you can do on the language design side that would have a large influence on whether your language is adopted or not. In either case, it's like time to market wins, and that's basically being at the right place, like being employed at the right company at the right time, and yeah, not much you have that you can control. So one of the chapters, and you will see and you see that the slides will get even worse and more confused and even more incomplete, because that's stuff I'm currently still working on.
Right. Just roll through the things a little faster, and then we'll have plenty of time for discussion when you get to the
All right.
places
So
where
one of the chapters I mentioned earlier is avoiding past mistakes. And there are some, as mentioned, low-hanging fruits of things you can fix in your language. And one of those low-hanging fruits is basically the bitwise AND operator and its precedence. And the thing is, if you copied the operator precedence of the ampersand from any of the popular languages, then the precedence is broken. And to learn more about that and read all the gory details, I just put a link on the slides. Feel free to read through it. And the fix in this case is just to give it the right precedence and move on. Staying at the operator topic is modulo and remainder operator, the percentage sign. And the issue there is that we have roughly 5 different semantics we can pick from, and people have written papers which one is the best, and nobody will remember which exact behavior your operator is going to use. So just use a function with a descriptive name so that people can navigate to the implementation, and then you can have a long Java doc or whatever documentation string in there describing what your semantics are for the function you have chosen. And if you're interested in the papers where people discuss this, I put the links on the slide. Another operator thing. I'm really not trying to make this about operators, but it's just so many low-hanging fruits that I couldn't resist. Bit shifts. So in languages that do not have unsigned numbers, you not only have the left shift and the right shift operators, but you also have this triple right shift operator, and the difference basically is whether it's doing an arithmetic or a logical right shift on the number, and confusingly the opposite of the double left shift or the double smaller than is the triple greater than, which is rather unintuitive. And my recommendation in this case too is just use functions with descriptive names. For instance, shift left, shift right with signed, and then things are really predictable and you've saved 3 operators. And one concern with functions, with replacing operators with functions is usually, well, it's more annoying, and you have to write like the parentheses for the function calls and so on. And it turns out, at least in these cases, people defensively sprinkle the code with parentheses anyway. So it's not that much more of a hassle using a function compared to an operator. So that's another recommendation. Another thing is consistent keyword placement, and with that I mean you have keywords that introduce or mark the places where your definitions appear. For instance, you have keywords for classes, interfaces, and enums. And some languages say, well, classes, interfaces, and enums, that's fine. But for methods and fields, we are not using keywords. We are just reading the name of the method or the name of the member, and then have a look at the parentheses. And if they are there, it's of course clear that's a method. And if there aren't any parentheses, then it's a field. And I'm arguing that's just, don't do that. And another example is keywords for functions, but not for methods. That's of course coming from JavaScript. Another example is from Java, where if you want to have static methods or fields, you have to write static in the class definition, but in interfaces it's automatic, at least if the method or field has a body, and also
What does
like,
that mean?
sorry?
Sorry, not following this one. So keyword for static members in classes, but implied in interfaces?
Yeah, I mean, if you have like a class in Java and you want to have a static field, you write a static final name of the field and its body. And if
Right.
you want to do the same interfaces, you can leave out the static because
Really?
it's
Things
applied.
I didn't know. I never realized such a thing was possible.
It's just since interfaces can't have fields, clearly static is implied. The same as like you don't
Yeah,
have to say public in interfaces because it's implied because it
exactly.
can't be anything but public. So
Yeah.
how do you fix that? Like you on classes you can have fields, right? So then
So
how do you disambiguate?
I have a different take, which is I just don't have any keywords, and then this problem goes away.
Yeah,
That's of
first
course,
is nice, but uniform is also nice.
I mean, that's also consistent, having no keywords, right? All right. Let's go on further. Another topic is consistent type naming. It's also like one of the low-hanging things. It's like people please decide on the naming rules you're using for your types. And if you're saying like, well, int has to be written lowercase because it's a very special built-in type known by the runtime, and strbuff isn't that, but it's a user-defined class and they have to have different naming conventions. Yeah, just don't do that. It's like have a look at the reasons why you're saying int is very, very special, and improve the design of your language that int is less and less special and behaves more and more like types users can define. And at that point, they should just converge on the consistent naming rules. And if you still want to mark your really special built-in internal types separately from types defined by users, don't do it with a special naming convention, but just let the IDE color the types in different colors and be done.
You can use lowercase type names in Java. I think there's no language restriction.
Yeah, sure, but nobody does it.
Nobody does it, but there's no requirement.
But every
Yeah.
time I'm listening to a talk and the speaker has to specify capital I integer or lower I integer because that's an entirely different concept.
Yeah, they have very different implementations and then performance. One.
Well, it's two different type systems. It's two completely different type systems. I mean,
Yeah. All right.
Okay, then maybe put on the slide, favor one single type system for your language.
Well, you have to tell that the primitives are often construed as a different type system. They have special because they're special in the hardware in a lot of ways. They're special.
That again, it adds to the complexity. You have to know about these two concepts and when to use which.
No, but it
This
matters.
is why reference types are a mistake, because you should just have single type system like int.
I mean, that was the old joke for Golang, was that it had generics, but only if your name was Rob Pike.
That's true. Yeah, basically it's like find out why you're trying to have two separate rules for naming and work on the reasons so that you don't need those anymore.
well, I mean, I agree in that it's good to only have one type system, but for languages that got stuck having two type systems because CPUs were more expensive, I mean, it kind of makes sense why they did what they did.
Yeah, sure. But it's like, I mean, you don't have to copy every legacy design decision into your new language from 2024. That's what I'm trying to argue.
I want to make it clear that these primitive types are still special in a lot of ways.
Yeah.
And the specialness shows up at numbers like 10x speed differences that are big enough that it matters, that you care.
Yeah, I'm not arguing that we're boxing every single number, but arguing that we try reducing the friction we're exposing to
Okay.
users
Yeah.
until they are
The-
similar enough that having different naming conventions for them is not worth it anymore.
The question should remain when to expose the user to these concepts. So the best thing is here to me at least is to delay the decision to choose which one you want. So the ability to delay that decision as long as you want.
I think they should be exposed pretty early on. It's a fundamental law of physics for a lot of these primitives. And they're not
Yeah,
going to go
but
away.
for a newcomer, this brings a lot of the internal stuff of how computers do stuff.
I think that's fair. But that's an education question, and I'm not
On-
teaching these classes, so I
On
don't.
the same point, this is the garbage collection is held accountable on the same point.
Yeah, GC lands in that category.
Oh.
Oh, do this one. Yeah, go ahead.
All right, so another thing is use your available brackets and parentheses and curly braces responsibly. Don't
Angle brackets for generics. Come on.
yeah. So basically
Yeah,
my recommendation is just pick one distinct use case for each of them and stick with it.
Arrays.
Like
What do you do with
the
array indexing? You don't have array
round
indexing there.
here it's
You have
under
groups,
parentheses.
expressions, parameter args, sequences. Usually array indexing's on your squares with your type parameters.
Yeah, I mean
Put array indexing on the slide.
array indexing is just a function call.
So you should put it on
Yeah.
the slide, and immediately you'll get hate from a bunch of people, and then you have to deal with it. I think
Yeah,
that's a very
they have to
controversial
deal with it.
decision.
They have to deal with it. I don't.
No,
Yeah.
but if you don't, people will ask you, and then
Yeah,
they'll assume you meant
that's a good
square
point.
brackets for array indexing,
but
whether or not it's a function call.
I've definitely
the
seen
point.
students trip over parentheses where it's like a list of things in parentheses and a list of things in square brackets, and one's a tuple and one's a list, and they're the same except for when they're not. And students do trip over that.
We are going on the waters on what is familiar. So
Also, one point, just on this last slide you said we should have one consistent spelling, like only lowercase integer, but not uppercase string, right? Well, by this argument, there is no reason to have type arguments to use different spelling that ordinary function value arguments. I mean, you have to argue for this.
Yeah,
why
I
do
think
you want to make two different type systems?
exactly.
Sorry.
No, go ahead.
No, this is exactly the thing I thought about yesterday. Basically, I looked at some of the pseudocode in my own language, and I have I use the same syntax and use parentheses to construct objects. Like, so I use them for constructors, for structs, but I also use it for function calls. And I also use it for passing in type parameters. So I use basically parentheses for everything. It gets very confusing if types can be spelled with lowercase letters. So that made me think a bit, and I was thinking or considering that to just have types require to be spelled with uppercase letters, and then reusing parentheses doesn't become so confusing. Like, you will see if something is a constructor or a function call just by the capitalization of whatever you're using the parentheses on. So
I'm on the other kind of the spectrum. I'm on the opposite, because you need them to distinguish them syntactically for implementation reasons, to distinguish what is a function call and what is a type parameter. So at least to me, I like them separate.
Yeah, fair. In my case, sorry.
No, go ahead.
So yeah, exactly. Like in my case, I'm lucky because since I'm doing a single pass thing, I have like all the types already ready, and I can distinguish it during parsing. and I can distinguish there. So this is, but honestly, that might also be like a poor design down the road. So I'll see about it. But yeah,
It depends. It depends.
Yeah. I mean,
So type parameters are types, so
the thing I'm
definitely
arguing,
keep the naming the same.
the point that Adrian mentioned. So what I'm saying, basically, you're saying that okay, this is going to be an issue, telling terms and types apart if you use parentheses for both. So maybe introduce the rule of types always have to be uppercase. And I think I think I agree with that, but I would also go one step further. It's like basically, I guess at every point where I say I need to have a disambiguation between A and B, I'd work with the principle to not only have one thing that clearly disambiguates those between A and B, but have two things just for safety that if everything falls apart, you still have a safety margin left. And on the core question of why treat types and terms differently syntactically, I mean, it's a very good question, and I'd argue that in, for instance, dependently typed languages, that's absolutely the thing I'd go for. Have like the same type of bracket, because there is no difference between the value and the type anymore. But in languages that still have this distinction between values and types in many, many places, I mean, it's like things like, can you have named arguments? Can you have default parameters? Can you have inference? There are so many slight differences in how you want value argument lists behave from how you want to have type argument lists behave, that I really say in this case there is more benefit in clearly separating them one from another than there is from trying to unify them, at least as mentioned in languages that are not dependently typed. I mean, it would be really cool to unify them, but I see that in the details, the semantics that people want are just too different. And basically, last point is, generally avoid language splits because they are really, really expensive. And examples for language splits are gradual typing, which means you have static typing and dynamic typing, nullability annotations, which means you have some types that are nullable and sometimes that are some types that are non-nullable. And the last example is method coloring, where you have different kind of colors signifying different kinds of concurrency being used or being
Isn't
executed
Kotlin
on.
doing nullable, not nullable with, question mark, like not the giant annotation?
Yeah, that's basically, yeah, it's basically the same. They have like nullable types, non-nullable types, and because they have to interop with Java, they also have these types where we don't know the nullability, and that gets really complicated really fast because the total complexity of these bimodal splits in language is usually not just the sum of those parts, not just static typing plus dynamic typing, not just this part is non-nullable and this part is nullable and so on, but there's extra complexity in making these two parts of a language work together, and it's really been worth it from what I have seen in the last few decades. So if you can, avoid it. And I think that's basically the end of that chapter. And I have like this, you ain't gonna need it chapter. with like some smaller things. One is I think Cameron will like it a lot about operators and how many you should have, and I'm arguing try to get away with the most minimal set of operators because they're rarely worth all the effort and the complexity that one might tend to put into them. Just pick the 10 most popular and skip all the rest and spend your effort on other parts of the language. Another thing I'm arguing that you're probably not going to need it is the new keyword, especially as used in some languages like Java or C#. And I think there's like one reason that that stands out most, and that it's for many people rather unintuitive how the parsing works. So I have one additional parenthesis here that you should ignore because it's wrong. And yeah, maybe just try and fix it. Okay, I can't find the
Backspace.
I have invisible ink and white
Oh, that works.
fonts because the
Spacing.
space is not the same width
Yeah.
because the font is broken. So I think one of the rule that's enough for me, one of the problem that is enough for me saying, well, let's not bother with it, is basically people have trouble reading it and it's really unintuitive. So if you have like this new sumtype.foo, should it be parsed as new sumtype and then .foo, or as new sumtype.foo read like parsed in first? And if you look in Java, for instance, at Java, you see that that's the first interpretation, basically the second row here, is the rule being used. And no, it's not. The third line, that's the thing in Java that's being used, and that's rather unintuitive, I'd argue, because that is really beneficial for when you use inner classes in Java. Then you're really benefiting from this rule. But in every other case where you create an instance and want to call methods on it, it's really cumbersome.
So
And
in
the
Java, you can't have the parentheses on the sum type. So it would be new sumtype.foo, open close parentheses.
You mean here, if that would
Well,
be an
for any
outer
of them,
class?
if it's an inner class, it would be
Yeah.
new
Yeah, then yeah.
sumtype.foo parentheses.
Yeah,
I don't know if
maybe
that
I have
matters for
to.
your example.
Sorry?
I said I don't know if that matters for your
Yeah,
example.
no, it doesn't. It's just like I haven't come up with a better example, I think. Yeah. Good point. Yeah, I'm not sure. Yeah, maybe I just need to improve that slide. Yeah, that's basically that chapter. It's like need to shuffle things around, maybe add some more slides there. And the remaining one is doing more with less. And in that chapter, I basically argue for unified condition expressions as a replacement for the various kinds of if constructs, switch case, pattern matching, ternary operators, and so on. Basically, I'm arguing that having one slightly more complex construct is beneficial to having 3 different simpler kinds of construct. And the core thought of these unified condition expressions is that it's possible to have a shared in blue and a specific in green part of your condition, And if you need it, you can basically split your condition into multiple specific parts as if it were a switch statement, and you get all the power or even more out of it without having to have an if and else and a switch case and a ternary and so on. The other part I'm going to argue is for a type of union where your union definition refers to existing types when you define the members and not let's say it like this, the members of your union are not defined when you're defining your union, but they refer to already existing classes. And that enables for some kind of interesting things that aren't possible that easily. For instance, you can just build unions across modules referring to various types. And of course, you can have like multiple unions referring to the same types. And for instance, builds this JSON value union out of these 5 existing types that are living somewhere in your standard library without having to have the customarily required wrapper type around it, for instance, like in Rust. I think that's something that I still need to explore more. So the slides are kind of raw here. The last thing I have in this category is saying, well, how about having consistent keyword lengths? Just because why not? It's like it doesn't cost you anything. It's kind of nice. It's kind of cool being able to define what the keyword does. Just in saying, well, how long it is.
Yay and nay.
Exactly. Yeah, maybe the true and the false is, and yeah, exactly. And the thing is, people will of course disagree. They say, well, case is ugly. I want to have if, and I don't like loop. I want to keep using while, and exit is weird. I want to use return or something.
So
and
a couple questions in chat for you.
Yeah, and I say fine to all of that. If you get 80% to the goal, it's still an improvement in my book. So
break and continue for control
yeah,
flow.
throw it out.
Continue.
Nah, we don't need break and continue. Just throw it out.
Just don't need them.
Yeah.
Wow.
Yeah, maybe that's something I should dedicate a slide on. All right, and conclusion is, yeah, if you're building a language, just stop worrying, have fun, maybe use some of these ideas or suggestions to get more things right than predecessor languages, and always consider keeping your language as simple as possible so that you have plenty of complexity budget left. I think that's it. Thank you. I'll stop sharing because I can't read chat. It's just too many things that are forced to be on top of each other. Thanks.
Yeah.
Did it stop sharing?
Yes.
Perfect.
I have a comment. When I made my reserved keywords underscore and a capital letter, everyone hated it, especially with on break, on continue, and on empty.
But
like, I don't think consistency. Yeah, I don't think they appreciate any consistency.
That was
it's just
part
me.
of the weirdness budget.
Yeah, did your other keywords also start with
appreciation of consistency? It's appreciation of consistency across other languages.
Yeah, a lot of folks use break and continue. Those are around the block ways.
No, that's the thing there. Like you can prefix all your keywords with a percent and a dollar sign, and it will be very consistent in your language. But people look at it and you're like, what is this? So I think consistency there, it to some degree spans languages. And of course, inevitably, you're gonna have to break some patterns there, because otherwise everybody makes the same language, at least syntactically. But there are, I would say there are things there that make sense, which is a bit of a weird way to describe it, in that if you, for example, if you reserve things that start with an underscore and a capital, that doesn't occur, as far as I know, anywhere else. So that's where you're looking at, like, well, why underscore capital? Why not something else, right?
And are all the other keywords also starting with underscore and capital letter? Because if
Right,
not,
but if you,
then
for
it wouldn't be
example,
consistent.
were to use, let's say, double underscore, that's, I personally think it's still stupid, but that is a pattern that you see a bit more often, where like Python, Ruby, and probably a couple, they have like special constants like underscore, underscore, file in capitals, underscore, underscore, and things like that. It's terrible because it sucks for auto completion and typing, but it's more consistent. Like it's adopted. So if you're going down that route where you insist on, hey, I want to have some sort of prefix and some set of capitals, that will be more consistent. But I would argue that if you're going down the path of reserved names, just make the proper keywords.
Hey, Simon, can I put the path to the keywords in the doc, path to the slides in the doc? You're muted.
Did you, or shall I just
You can put them in the, I don't care. I was gonna
all
copy
right,
from the
yeah.
chat, but I wanted to ask.
Yeah. I pasted it in.
And maybe somebody will.
Oh, there. Yeah.
You put them in the links.
Yeah, somebody, yeah, it's
Okay,
great.
fine.
It looks good. Yeah.
Okay.
I
So-
think I have one small thing to add to the brackets. Something that might be worth putting on slides is that if you, for generics, whether you use square brackets or parentheses, doesn't really matter. But the benefit those brackets have over the comparison brackets is that virtually every editor that's worth mentioning will auto insert the closing bracket for square brackets, parentheses, and curly ones. But they won't do that for the angle brackets, because they're used for comparison. So if you do something like, list your brackets, int, whatever,
It's
basically every
a-
editor you type list bracket, it already does a closing one.
Yep.
With the comparison ones, it won't.
Yeah, it's an
Similarly,
extra tax on every time you write a generic type.
right. So it saves you a bit of typing. And similarly, case there is Rust using the single quote for lifetimes, which is really annoying because you cannot then, because they also use them for the character type,
Yeah.
but then with double single quotes. So in specific contexts, quote letter means lifetime, or quote word specifically. Then in other contexts, quote something, quote means a character.
Yeah.
Which means you cannot autocomplete single quotes, because if you type them in lifetimes, it inserts an unwanted closing quote, unless you do contextual completion with like tree sitter or something like that. But basically no editor does that.
Yeah, I mean, that could theoretically work right up until the point where they added literals to their type system.
Yeah, so I
Right, where
believe Rust does
can-
have const generics, but I think they're currently restricted to integers. I don't know if you can use characters.
Yeah, I mean, a character is only
But
an
yes,
integer,
there
right?
are limits as far as you can
Yeah.
go with contextual completion. Better to just avoid the need for it in the first place.
I mean, they also have, I think, some disambiguation rules for literals and const generics, where they require curly braces or something around them. If
Yeah,
if
the disambiguation rule for const generics is curly braces.
all right.
But like this is also for like if you have expressions and stuff, things that are a bit harder to parse. If it's just a number literal, you can put it in there. But yeah.
All right. Yeah.
I had another point I was curious, maybe you could also give another example for this unintuitive parsing rules, or yeah, I guess I don't know if in which slide it would fit, but I think if you have some kind of in the grammar, like a element that is a prefix or it comes at the start, and it's weakly binded, something like a reference dereference operator or something, or an await keyword, try keywords, they cause usually like like a huge mess of parentheses.
Yeah.
So like preferring the postfix option,
Yeah.
or maybe like either having the option to have a postfix version of these operators, or just making the
one?
postfix by default. Like for example, reference and dereference operators. So
I was thinking of instance of in Java's is whatever the wrong order. You always have to parenthesize it, like do not instance of.
Right. Yeah, basically, whenever you have like these operators where for some reason like you find yourselves adding lots of parentheses, I think this is a good sign that you should like fix the order. And a lot of times, like that's a huge source of like legacy, carrying legacy. Like a lot of times it's just because C does it, or C doesn't do it, or Rust does it, or whatever.
Yeah, I mean, you're making a really great point. Or I just changed the slides. Yeah, I mean, I think basically the key insight I got from the thing you said is that the problem is actually not like the new keyword, but it applies to all prefix keywords or operators, and maybe that's instead of saying, well, don't use new, which I think there are other points for it. Have a more general slide in the presentation about avoiding prefix keywords and prefix operators in general. I think I'll change the slides because that makes much more sense.
Right. The funny thing is, if it was a postfix operator, like maybe it was like class and then dot and then new, then turns out that actually looks like a constructor function. So and then you arrive naturally at a like at a place where maybe you just use functions in the first place.
Yeah, I completely agree on that.
I actually don't think you need the new keyword necessarily. I think in this case, what C++ does is okay. Just type, name, and the parentheses. So if you want to have a class of type T, you write type T, semicolon, and that's it. It's constructed. There is no need to type T equals new type parentheses. I mean, it's just...
Yeah, the thing why I basically I agree on just use parentheses, but the thing is why I also want to have like backup, like you remember these rules of two. I want to have like some backup for basically I say, okay, I have like I construct a new instance of a type with basically around parentheses. And then I say, okay, I have this other rule in the language that if my method is called apply, I can leave out the function name and can also just use round parentheses. So if I want to, for instance, create a factory function for my type, I define this apply method and it will look like a constructor call basically, with basically the difference that compared to a constructor call with factory method, I can also return like an optional or a result of the type or something. Doesn't matter much, but the thing is, if I have this apply function at some point in this factory method of my type, I actually need to create this instance. And if I already have like the syntax with like the parentheses already used up in that case for my factory method, I need to have some other way of saying, well, now I really, really want to call the constructor of this type. And that's maybe the case for saying, okay, type dot new parenthesis is a good way of achieving that. Not sure if anyone could follow. Sorry. Okay, probably not.
Yeah, we got it. At least I got it. Oh, if there is a topic or some more questions.
Yeah, sorry, I'm off in the weeds doing other things. I'm back.
I wanted to say one other thing, like for the constructors and having the same syntax for two things. There's one way I conceptually thought about it, like in my language. Maybe I can shortly share my terminal. It's just a little snippet. I can't see. All right.
You can just share an individual window and then.
Yeah.
And a lot of these things, I'd be happy to throw out my AA version of the syntax just to compare what you're.
Yeah, I think it's good. Like if we put like different people's languages in the docs and then like but basically so foo is a record. It's a type, and okay, I can call the constructor like this, which is the same function call syntax, which is a bit fishy. But like conceptually, how I think of it is that foo, in this case, this identifier actually decays to a function which has the same name. So foo in this case is actually a function in the constructor, and I can pass foo to any other like function that accepts a function. Like for instance, if I have some kind of like,
so for AA, I'm doing something conceptually like identical. The definition for a record in AA gives you a type foo. It also gives you a function foo, which happens to be the constructor. Then when you say foo in a value context, you get the constructor, you get the function pointer, the constructor call, the normal function call.
Right. I think this is sometimes like this is found in different places. I feel like I describe it as a kind of like a decay where you use one thing to reference something, but actually it can like change its type or its status. Like instead of being a type, it becomes a term, but use the same syntax to like treat it. And yeah, this is like an example. So right, if you have something that expects a lambda, and like this thing itself is a function. So yeah, it's a bit similar to AA. We discussed it at some point in the earlier CCC, but yeah, that's.
Yeah. What was I going to do here? So I have. Let's go pull up Google Docs. Let me hit the share. I think I'm not going to say anything new and exciting though. So, constructor. So for me, I'm going to use an uppercase name for a type, but I don't care, is equal to colon means I just made a type description. So I'm assigning person as a type name. I'm going to not get auto completion by Google. Thank you for nothing. That's a struct. Person is a struct. It has an age field, which is typed to be like an int. He has a whatever you want to call it here, a tax field, which I'm going to assign it a function that takes something, I don't know what, and does some random computation, and that makes me an instance method. When I want to use it, then the act of defining person gives me a type in the type space, and it gives me a function in the function space for a person. And so person per is equal to capital person. It's a function call, and I just call it, and I get a new person object. In this case, because I have a field that's not otherwise defined, I have to put an age in. So I probably want to have a name in here. And then I want to say, like that. You just call person, but it's a normal function, so you can pass it as a function off to somebody else.
Out of curiosity, what was the motivation for choosing the @ symbol for a structure?
Well, so I went around and decided I wanted curlies to be consistently how the weirdness budget versus simplicity. So curlies in most of the current languages that I've looked at are either used to define parts of structs or classes, and also they're used in function bodies. So I kept them for both. but I needed a way to distinguish lexically, syntactically, whether you intended to write a function body or you intended to write a class structure. So I hunted around and I picked up at kind of arbitrarily, and I'm still not entirely settled on it. If somebody wanted to propose an alternative, I'm open to it. You can imagine replacing at with the word class. And in my, hey, I'm gonna try this no keyword hack, it's still a hack. And so, hey, I'll just, do this, fine. And I demand no space, so there's no weirdness in the, you have to tell them they're together. No reason other than I needed something there. You could put patent this, you could put %, you could put dollar, what the hell
Fair
you want.
enough.
Or I
You picked it because curly and the at sign is most convenient when writing cursive by hand, right?
I could have said something that was not my thinking. I don't know where I got at from, other than I wanted something that wasn't currently being used in other contexts. And I wanted to keep the curlies to say you're a struct or you're a function. And the syntactically they're almost unambiguous. So they're not quite unambiguous. There's very few places so that I could just say it's a struct or it's a function, but the writer or the reader would have to stare some number of tokens in before they could distinguish about whether they have a struct or a function. So I didn't want to. I wanted it obvious to the eye before you started in on the body. So that's why the at's there. And then, after that, I get into a bunch of other AA things that are kind of orthogonal to what you said. Let me see if I can cover some of the same ground. So I have operator overloading in the language. I think I have it done in a very consistent, similar way. Any operator can be called as a non-operator, as a normal function. So 1 + 2 has the plus as an operator. So just this alone is the name of the operator when you're trying to refer to it as a field, where the underscores show where the arguments go. So this is a binary operator. So if I do 1 dot plus, then this is a field load of the operator. And this gives me whatever an operator is defined as, which if it's a normal function, it would give me a function where I've pre-bound the first argument to the number 1. So I don't get a generic, I'm an add argument that needs 2 arguments to run. I get a 1 pre-bound. And then I get into my overload field thing, which is not any part of what you're doing on your slides, except as it's part of the language new things, where the under field is the one where dynamic field load, whatever. It's a typing system infers.
One thing I think you should really do the teaching test there, because like one thing I always benchmark like the various features against each other is saying, okay, for instance, there is a tutorial that somebody is doing on my language, and there are 20 people in the room that are sufficiently smart and interested, and the presenter has 45 minutes to show the language in a way that people understand it and might be able to write some small example programs.
Right.
How many minutes of these 45 minutes will be eaten up by that operator overloading cleverness? And is that really the best part to spend complexity and time on?
I would claim 0, and I wouldn't present it.
I would even say negative time, because if you think of teaching this to non-programmers, but people who work with physics or chemistry and want to work with linear algebra, they expect to be able to write matrix plus matrix or matrix times matrix. This is what they already are doing on the pen and paper. So if you tell them, no, you have to use keyword and you have to learn this keyword is dot multiply or dot add, this is new, this is strange, this is unexpected, and they will have to have hard time recognizing the equations they write on paper comparing to what they have to write in the language. So I think it's a negative budget.
Scientists will use Python and will rather complain that our programs are too slow 100% of the time.
That's fair too. That's fair too.
So like, don't try
would
to
say
send your
that-
language to people that aren't interested in buying it.
I mean,
The-
you do operator overloading in Python, but it's not the first thing you teach about Python. So there's an operator overloading. Okay, there is, but
Okay.
I'm not going to teach it in your first 45-minute
Okay,
class.
then I mean that the time span doesn't matter. Then say like it's okay, it's not a 45-minute tutorial, it's a 1-week language course. And if that doesn't that's not enough, say it's a 3-month work on your own book.
There's
And
there's the 1 hour version, and then there's the 1 week version. And you
yeah,
get
but
things in those two classes.
but the same question also applies there. Like, at which point in the learning journey of a new person will you put in this topic,
It's the same
and
place the
which
Python guys do.
and which other topics are coming before and which are coming after,
Right.
and which topics will get the cut in the,
I
for instance,
claim
in the
this is-
1-week tutorial or something.
This is well-trod ground, and I'll just follow what other people who do operator overloading do. It's never the first thing that comes up.
Yeah. Ruby used to talk about this principle called least surprise.
Right.
So basically their philosophy was just if people expect something to work that way and it's okay, then they'll make it work that way too. And so you end up with like a variety of ways to do things, but it actually made the language pretty easy to get people up to speed on. And then maybe it took a little longer to become an expert, but you know, most people never actually care to become an expert anyway. So I don't know if that matters.
So there you go. For the case of the extra operators, I don't really care to define them right now, so maybe I won't have too many to begin with, but I have to pick a precedence to get the parser to deal. And then you can pick whatever you want, so that's more operator overloading things. You can pick any kind of operator thing you want, but the precedence is defined such that the parser can discern it from the first few characters.
So as you at least you have a fixed set of operators that
there is a
can use.
Well, no, there's a fixed set of operator lead-in characters.
All right.
Any other operator characters after that will make a unique new operator, and the lead-in characters define the precedence.
I mean, isn't that also like optimizing for the expert user at the expense of the average user?
Not at the expense, because the average user won't ever write a new operator, and then they don't care. And so that complexity will ever be not visible to them.
And the expert user will hand the average user a document saying, oh yeah, if you want to do this fancy thing that we always have to do, just use this operator.
Right. And they'll make it up for them. And the operator will be limited to operator characters, but you know, the average user won't know. He'll just fold it in like it's another version of multiply, like the exponentiation being 2 multiplies, right?
Yeah, generally the rule of thumb is look at what C++ did and do the opposite.
Maybe. I don't have any good answer for div mul versus divide versus remainder operator. I don't use the remainder operator. I don't see it used very much, so I'm happy to use a keyword there.
You know, function name.
A function name. Keyword, function name. Yes.
It scared me for a second.
I didn't mean, I meant to say function name. Now I have function names that come off of, well, that won't help you any. So that goes straight to the complexity budget that no one cares about. You know, dot div mod of 17. And that gets me the first character that is div mod of 100 comma 17, except that this is in the integer namespace. And I don't have an integer namespace.
You probably mean div rem.
Probably not div rem. Yeah. right? Instead of math.rand of 2, I would have 2.rand. And then same for math.min of 1, 2, 3. And we're going to have, 1.min of 2.3.
So do you allow where would the rand method come from?
Where would
Would it have to be in the place where the int gets defined, or could it also be in a third-party library that defines the
yeah,
randomness?
so the 2.rand comes in the int place unless you're going to override int,
Okay.
which you could do and add a third-party rand call. So this would give you
Okay.
some version of a system rand. So if you added a third-party guy, then yeah, you'd just call it how you expect it, whatever random.rand of 2, wherever random.
I mean, at this point, I think it's like you're bundling your most basic types with functionality, in this case randomness, where you're maybe not where you're maybe not well served in
I'll agree.
being bound by the same compatibility promises than your other methods on int, because randomness is complicated, and
no, anybody who comes with a text name has a chance to be overridden, and random is one of those. So it's all fine in the sense that
the other person would have to import their rand, and then you could use 1.rand, and it would be the random.
yeah, you'd have to define a type which extends int, which has a new random, if you wanted to use this syntax.
But would the rand methods then have to have the same arguments than the standard library one?
If you're overriding the integer guy, then yeah, it does, because that's an override. If you're just extending the integers with a new random with different arguments, that's also allowed.
Okay.
Are you planning on having the ability to reopen classes? And basically
you can not reopen, you extend.
Extend. So that, but then is there a way to say my integer literal will use my extended integers?
Yeah, I decline a new type, and then I'm saying it's a type that's defined as an integer, which is extended off of, which is extended with some new fields. And I want to make a new field in here, and the new field is rand.
Yeah, I understand that, but what I'm asking is whether if I now say 3.rand, I'm going to get your myint, or I'm going to have to somehow, like, I'm still going to have to instantiate myint.
I probably will have to have you, so then now all things are sorted out here, but I probably have to instantiate a myint. And given the right rules on how you extend it, I'll implement it as an int.
Why not the extension method route? You just import and then you need to override if you call it route.
So there's this notion of, because I have the operators done the way I do, I can do text name operators as well. What are the limits and usefulnesses of that? Well, I can do 1.min. It kind of works out okay. 1.rand doesn't work so nicely because people like different random number generators. So then it becomes, can I extend or override, or should I just drop rand off and say, you got 1.min, but you don't have 1.rand and you can't extend. So what can I get away with here, but syntactically valid and sort of matches the operator execution model? Well, I can do some extensions that say, if you only have final fields, like rand equals is a final field as an extension, then I can keep the same implementation for ints. So now when you come along and you say I have a 3, what the hell is that as a type? Well, I'm still going to in the partial claim you're a lowercase normal int. You're not a myint. So now I have to have a myint. And I have to go get a myint somewhere in the world, and myint of 3, and it extends int, so I can put it in some var x, except I don't have vars, it's just untyped, and that will look like an int and be usable as an int context. But if you call it .rand, you'll get the other version of rand.
That borderlines a new type, but the extension methods are so common, so they warrant light syntactic implementation.
Sorry, I'm having a hard time hearing you, Theodore, and I'm
Oh,
trying to catch up on new messages. Oh, do the opposite. Yes, hello. Yeah, okay, fine.
Yeah, you have the best audio setup, Theodore, but you're like the least loud.
Can you hear me
person.
now?
Ah,
Now?
much better.
Much
So,
better.
so I wasn't switched the microphone. So yeah, here we go. So this implementation is like a new type, which is an instance of mine, but it can be interpreted like extension method. So the extension methods are so common nowadays that they warrant light syntactic implementation. So this is too heavy for extension method.
Okay.
That's my opinion.
Okay, so I'm living within my current syntax bounds, and if I come around to adding more syntactic sugar for cheap ass methods or whatever extension methods are, then that'll happen at a later time.
So
right
extension
now,
methods are so
Look-
common, that they weren't.
so common that I've never used them in my entire life.
I wouldn't use them either.
Okay,
Well,
I use them
I
all
think
the time.
that
But
within the
the-
context of your own library, it's all fine and dandy. But as soon as you're importing a library that's got some crazy extensions, that's when the fun really begins.
Yeah, I'm
I'm-
not clear that I'm ready to go
Yeah,
there.
I mean, I'm at a position that I even consider Java static imports a mistake. So extension methods are a hard sell for me. But
Alright.
the thought I had, Cliff, on your semantics regarding the rand is that if you're going the route of saying, well, we are looking at the exact signatures, and that's then either overriding or overloading. I think that will be an issue in terms of modularity, because if you have like a third-party library that says, well, the standard library random methods are crap, we are providing our own better methods for it, then that library basically has to play catch up with the standard library every time you're extend or overload these rand methods in the standard library, because they immediately have to release a new version of their third-party library that overrides the methods that you newly defined.
Oh, if I put new methods in the standard library that you can get by calling them off of a dot integer, and somebody else wants to have their own version that they get off of dot integer with this bad extension syntax, then there's a name conflict and they have to decide. Is that what I heard you say?
Yeah, I mean, it's like they basically have to play catch up. If you say,
no, that's because back up a step, because that's not what's going on here. Because to get an extension off of 2.rand, like 2.rand, you have to make a new type, and your type will extend and cover the old type, and there's no
okay, so you're not allowing switching out the rand simply by importing.
No, it's not a switch out, it's an override.
Okay.
The old one exists.
Okay, yeah. And on your my end, you also can't call methods from int directly on it, or how does it work?
Yes. You would call methods on them just like you would expect.
No, I mean, on my end, you can't, for instance, call plus, right? Because
like that.
Okay, but then I mean, then that's the case. I am saying that happens. That if every function on int is automatically callable on my int, that's basically the third-party library having to play catch up with the standard library. But because every time you add a new function to int that they may disagree with, like a bad random number generation function, they have to add their own function to override it.
Okay, so it's just a different interface. If you don't wrap that new function, then the callers of you don't see the new function.
Right.
So what I heard, it automatically exports all the members of int here in here, so you can still call it with a plus.
Right. That is, if I don't have a rand, and you want one, and you make an myint that has a .rand, then later I add a new .rand in the library, it slides underneath in the base library. You've overridden already. So the myint continues to use its existing rand, covering or shadowing the new rand I just added.
Yeah,
Reminds
but
me a lot of JavaScript's prototypal inheritance. You just follow the chain down.
but if you're adding a new rand method to an integer, either with a different signature or either with a different name, the other library has to play catch up and override those methods too, because it would be very confusing if you have like this myint.
But that's a different problem. That's the problem that says, I have a base library. Oh, I'm extending it. It does something new. You wanted to have a complete cover over the base library, but the base library is a moving target, so it's difficult to have a complete cover. That's everybody everywhere all the time. If I have a moving base library, system base, then and you want to do a complete cover, you have to match the new cover. I think that's totally fair. If on the other hand, I've added a new rand that takes a bunch of arguments, like say a seed or something stupid, and you don't cover it, then you get your covered rand and the new base library rand that includes the extra arguments.
Yeah, and I think that's might be undesirable. And
you're saying that if I go to Java and I have capital I integer and I add, 2 raw double bits, no one else is thinking they're going to cover all capital I integer, so no one's complaining that 2 raw double bits shows up. You're telling me they do complain that 2 raw double bits showed up because that wasn't there. Now it is there. They haven't covered it. In order to cover it, they have to do.
The difference is that in Java, those methods on integer don't get automatically re-exported to a third-party wrapper type, like with myint in your example.
Why? If I'm subclassing capital I integer, I just got them extended directly. Sure.
Oh, all right.
So
okay,
this
yeah.
is the,
Don't
this
subclass.
is the,
I mean,
I've made my int look like
even Java made their integers final, right? But
yeah, but if it wasn't and I overwrote it, then I gotta, this is, my int is like a capital I integer in Java that is not overridden and that I know how to actually bake it down to a fucking primitive int.
I mean that, but that's also like the 2 steps of separation in Java. A, integer is final, and B, there is no random method on integer. So that's like 2 layers of safety.
Yeah. If somebody comes along and adds a random method to integer, is anyone going to care? No, they're going to live with it. In fact, 99% of the time I'm calling random on integers.
But they can live on it because they know that nobody subclassed it.
No, but there are plenty of classes in Java that get subclassed and they add new things under there. Every one of the collections and maps and whatever, so the concrete implementation classes are not final. They're expected to be overridden and people add new things to the base. It happens. I claim this is not really a fragile base class problem. This is something, it's a reasonable expectation that the base gets extended over time and your override classes pick up new base methods over time. They don't change which methods you called. No one could have called the new methods directly because they never existed before. So it wasn't like your code changes because I added a new base method.
Yeah. I mean, one could argue that in Java, they, at least for the JDK, they have just given up extending popular non-final classes like collections because they are pretty much doing default methods and interfaces now, and 98% of the time because
is your
compatibility issues are way lower.
Okay, wait, back up. Is there thesis that this is the correct answer? They should not extend. Like, that's the thesis that says I need to pick a base library set and then never extend it. And if I don't get it right the first time, I'm fucked.
So one question comes to my
make more things final or reduced amount of the exports you have. Both, I think.
Well, I have, right now I have 5 exports or 6 or something. So
one question comes to my mind. What if we want to abstract? So there are a few implementations of big int, let's say, And they have a respective random fields. How can I write the code to abstract the I know that it will be an extension of int, it will have the random method, but I want still to use the int methods inside my code. So the code has to know that it will be extension of the int with the run. So you can use the other int code.
So if you don't use nominative typing, you get duck typing. So if you don't say otherwise, duck typing says you've used an int. It wants to use a factorial method or gamma function that doesn't exist. When it comes type to typing, the inference engine will say better be a subtype of int with a gamma defined, right? This is a case where you've used a method that doesn't exist. So 3.gamma, whatever the hell that does, right? So when the inference engine comes along, it'll say, this is a raw int, there is no gamma error. But if instead I said, you know, I have some my int, which in your head has been defined as an integer from somewhere else, it'll have to be a subclass of integer that has a gamma function on it, because that's the duck typing.
Because I still want to use the int methods inside my code here in the implementations, but I don't know which big integer I will use, and I want to abstract over that. I don't want my int or any other extension class, if you will, that will be extended by int. So I can use the int methods, but I haven't settled for a particular big int implementation.
Yeah, duck typing. You haven't settled. When you pass it in, it has to duck type to type. So somehow in the world, you've got a thingy that I'm using suggestively named my int. It supports operator add. It supports a .gamma. At the time that you've passed in your my int, it better be a thing that supports operator add and a thing that supports gamma. And that could be an extension of int, and it could be a matrix guy that understands the add operator. And this code won't care. So that goes, you know, here's another version of the same problem that I'm very specifically making sure works. I have a factorial, it's a function, it takes an x, and it says if x is less than or equal to 1, return a 1, and otherwise I'm going to return x times factorial of x minus 1. Okay, what is the type of this function? It's not int arrow int. It is instead something that takes a less than or equal operator, a subtract operator, and a multiply operator. And int follows that one, but so does floats.
You can abstract over the type. That's taken to a type class. So you can abstract over the what can be with these operators.
I just need those operators, and they have to have the right signatures within the operators that they match the inputs and the outputs the right way. Because it's always x minus 1. So if I put a capital T for my type, this operator minus here needs to be typed to be t comma 1 gets me a t back. Maybe I use square brackets for type signatures. I'm not typing the right. No, you know what? It's I actually use the same syntax but in the type domain. So it would be, you know, like t and a 1 giving me a t back. And the less than is typed to be, you know, t and a t gets me an int 1, a bool back, if you like. And multiply does the other thing. Whoops. So anybody who matches that signature is fine. And that would be, like I said, this would include anybody who matches signature, which includes, for example, int, float, and maybe some hypothetical matrix.
If you name this, that would become a type class or interface or something that has that specification.
If you put a name on that, you can make a type name and then demand that show up.
No, I'm saying that this conforms to, at least to my understanding, that is a type class, and it's an interface in object oriented.
Yeah, I don't have a name for it. It just shows up in the typing system for free without me thinking about it at all. It just pops out. I can put a name on it, and then you can require that name, but that would deny people who aren't using that name when they type it.
Precisely.
Okay.
Without a name is a type class.
Okay, fine.
Okay, cool. Next.
Yeah. I think it would be really interesting to have like the different approaches to operators put on like a large board of complexity and power versus simplicity and limitations, and check for every language that comes around with like a certain point on this slide, and check, well, do you actually lose anything going one notch below in complexity? Maybe one should write
I
that up.
started from the thesis that I wanted to not have, I wanted to do type inference and wanted to not do special weird shit around ints and floats with widening operators, which got me to the place of, if I did operator overloading and you do 1 plus 2 times 3 here, I mean, 1 plus 2.3, that I can just operator overload my way to having a strong type system, because the add operator on ints has a float variant and an int variant, and the overload just picks the correct one. And then it didn't need any sort of numeric class games or C and like Haskell and ML and stuff.
Or just let people explicitly convert the integer to float.
I need to have this to other piece. I need to have this boilable down to reliably boilable down to simple math on the hardware. So in the end, I have to know that I have a float on the right and an int on the left after type inferencing is done. So in an arbitrary complicated expressions, I can tell you where the hardware is going to do, the semantics get auto converting, and the hardware is going to do.
I mean, converting it explicitly doesn't add any additional operations to
No. Converting it explicitly adds me syntax. If I come through here and I say, this is a type error, and I'm therefore required to say float or double or whatever your syntax is. Like suppose it's E0 and E1. And it happens that E1 is a double and E0 is an int. Now I have to cast it like this. And I'm like, oh, here's the bad keyboard hit. I don't want to cast it. I just want to have the system auto widen like I've had systems auto widen since the dawn of time. But how do I do that in a type inference way? So I went to overloads to do this one. Once I got overloads sorted out, I can turn it around and say, oh, I can also do it on like factorial here, and I can do it for matrix multiply, and I can do it.
So what happens if you widen that integer to a floating point number that's not representing the integer?
Same widen
precisely anymore.
Out of C and Fortran, and if you don't like them, you can define your own. So if you don't do anything, you're going to get C, Java, Fortran like behavior. If you widen a very, very large integer, it will turn into a double that chops low bits. If it's more than 53 bits long, you'll lose some low bits in precision, and you'll get a double, and you'll go do double math.
I mean, if the conversion is lossy, wouldn't that be like the point of saying, well, let the user do that explicitly?
Yes. I cannot tell that the conversion is lossy. It's the same as I have an int64 and I add 1. Well, at some point that rolls over and goes from a positive to negative number. And my option are runtime tests for big integer, which have these huge overheads, or just accept that people know when they do int64 math that they could roll over, but it doesn't happen because they're in a domain where that kind of situation would have long ago died for out of memory for other reasons or whatever. They're never going to hit it.
I mean, one of those is not lossy. The other one is if you subtract two integers and it overflows, you still can subtract the second integer and come back to the value you started with. But if you're converting your ints
totally
to
reasonable
floats,
to have checked int64 as a type in your standard library that says I do the runtime test.
And you asked for a checked int, you get a runtime test. Same story here. If you ask for it, you can get a runtime check. The default behavior in my head is going to be, it will do either lossy or overflow or whatever, like the way the languages have been doing for the last 40, 50 years. If you want checked, you ask for checked. And then one of them gives you
but I also want most of the code. I would like a lot of the code that I write for integers to be generic over whether it's a checked or unchecked integer. And if I happen to have a checked integer that's getting passed around, that just gets JITted and I get new versions of those functions that work.
That's what I'm attempting with factorial there. If you call fact with, here I'm going to call fact, I'm going to get a pair of a results back. I'm going to call factorial with 3, and I'm going to call factorial with 3.3, and both of these terminate and give me a reasonable answer. And one of them is a full double, and one of them is a bunch of integers. And the JIT will do presumably specialization on the type of the input parameter.
Let's say I have a function that takes 16 integers. How do I prevent that from becoming 2 to the 16 copies of the function for all possible permutations of integer and checked integer?
So there's a default compilation strategy here where I do the lookup on the operators. And that's part of the overloading thing that I sorted out in the last 6 months, was how to do that efficiently. But it will mean it will not be as efficient as just having integer or just having doubles. So the overload worst case scenario is I have a structure with a list of choices, list of function choices in it, and I'm handed an offset into that, and I pull out at that offset. So it's a load with offset. Now I pull a function out, which is the operator as a function, and I call it. So your worst case scenario here is at each of those operator points, there is a load that's based off of the X's class, and an offset which is passed in based off the X's type, and that'll get me a function that I have to call. So that's your worst case. I didn't want to blow up. Then the specializer does profiling things and says, well, I find the following patterns are hot and common, I'm going to do them. But the others use the generic approach. Same as a vcall in Java. There's a fallback path that's modestly expensive. It's 30 clocks instead of 1. And then I get it to 1 if you're an inline cache, and I get it to 0 and better negative performance or whatever if you're inlineable static. So there's a way to do these well, or well enough. But yeah, my first cut would be for this kind of thing, I'll specialize on you. So you might imagine the matrix guy just suffers and does the lookup, but his computations are big relative to the lookup costs, so you don't care that way either. All right.
By the way, this generic code was a good argument. I think that was Aaron who brought this up, that, and you gave the example with the factorial, but say you want to write a sort function that is generic over types of the arguments. That kind of implies you need to be able to have user-defined overloading for the less than comparison operator, because otherwise you would have to write H in every different sort function for every different type the user would have.
Yeah, suppose I say somebody wants to sort an array of you know, whatever, and it's an argument. I'll put a type on it so we all know it's an array of something. And I don't care, I can put a T in there. And then the sort does something, and in the core inner loop of sort somewhere, there's a test that says, oh, array of X is less than array of Y, and I do something different, right? And here's sort test, and then less than operator, so that the type of T is demanded to include a less than operator. And then specialization sides are less than ints or floats.
I don't think you can avoid user-defined operators if you would like to allow generic code like this.
Okay. Oh, I see. Yeah. No, I want to. I think this is a good use of operators. It's like you want to say in Java, you're comparable or orderable or something. You want to say, this is how I compare these two things.
Yeah, I agree. I don't think it's avoidable.
So instead, if you go the object-oriented way, if instead you want the T to be orderable or some interface, you just go to the operator and demand it. That's the side step.
This is inferencing. I demand an operator less than on T.
Yeah.
And if I want to declare a more narrowly defined type that also has an operator in it, anytime I want to have a more narrowly defined type, I have to use a name. So I can use, I think a classic example I've been using here is point versus not the point.
Mhm. Yeah,
Oh, not here. It's just, you can add a name and you become nominative typing.
Mhm.
So if I say a point is a type which has an X and a Y, and I'll let them all be ints just to make life easy. And oh, come on. And then I have a function dist, which takes a P, and dist says, oh, P dot X times P dot X plus P dot Y times P dot Y. Oh, I need a square root. I won't do any funny syntax for square root. So a math dot square root of this. Okay, there's a distance function. This one takes anybody who has an X and a Y that has an operator add and subtract and blah, blah, blah. But I could also make a version of dist. Back here, where are you going here? That takes a P, which I declare to be a point. So let's call this dist1 and dist2 for no good reason. So dist1 can be called with anybody with an X and a Y. And this is a valid call. Oops, God, the @ sign is a trouble for this. And dist2 fails here for the same thing. This is okay. This is fail because it's not a point. Right? But if I wanted to make a point for it, then I could just say, let's see here. I have a P, which I'm going to say is a point of 3 and 4, and then I'm going to pass P in.
yeah. Oh, you should say that this one would be more preferred for library authors. So
Why? One is more generic and one is more specified because I wanted to restrict the inputs on it.
But I don't see anyone who will restrict exactly the types unless it's absolutely necessary.
No, you're right. No. But you add type annotations because you expect a certain type, and it's great documentation. Type annotations are fabulous documentation.
Yeah.
I have a
So
question.
if you happen to know, yeah, I put it in there. Sorry, somebody asked a question?
Yeah, I was curious. What is the type? What is the signature? The type signature of dist1?
Of
Like,
the
is
dist2 or of which one?
dist1.
Oh, dist1, the signature. Right.
Yeah.
Yep. Up
Because
here it is a function which returns something, and it takes a it's a guy who takes an operator multiply and an operator add, and they have to be compatible with math square root, probably requiring a float. So I'm going to say the operator add here has to take a t and a t and produce a float, or call it double maybe. I don't know. I don't care. And therefore, operator multiply has to take an x and an x and produce a t. And there's no comma here, so I'll just pull those out. And I'm not using any spaces because I'm just typing badly here, one after another. And let's put some spacing and widen it out. Oops, widen it out a little bit. Putting it in line is not a great thing. It's an operator, so you have to name the operator name the way you would call it. So I'm getting a little better here. And this is actually probably semicolon because it's different fields. So the operators here are actually just fields. They're every bit normally a field. Fields happen to contain some sort of function in them. And then there's one more piece of syntax I'm not throwing in here, which is actually those operators could have overloading is applied. So they could have other choices besides these choices. That's done by putting a tuple and a dot, dot, dot saying, hey, more choices. So they have to have an operator multiply that takes 2 x's. And I guess the actual guy is a struct. One more layer out here is a struct for P that has a dot x and a dot y that turns into these things. So it's I want to name. So I'm not giving you names for these things. Internally, the infer will give internal names for them that are impossible to read. Junk names, but there's an X field which is typed as I would call it a Q, and a Y field that's typed as Q, and it happens to be that Q is this shortcut thing for what the hell's going on here, right? I don't have my right set of braces. So Q is a hidden internal name, X and Y, and he's going to return you a double because math square root's pinning him to double in the output. And then Q says, well, I have to have an operator which takes something, and a plus it takes something that comes out of the multiply, and I'll get a double out. So you get a signature, something like that.
So yeah, but if you have to specify it, it will be a nightmare. So
Right.
that would mean if you are sticking to generic parameters, you shouldn't be type them. So
Right. If you don't,
that's
right.
kind of caveat.
Yeah, if you don't want to do anything special, you don't have to do anything special. You're done. If you're a
No,
custom
I mean,
language writer and you're
yeah, I mean, if you write the dist one, you shouldn't write the explicit type for it because it will be a nightmare to
it'll be a
express.
big, thick, hairy inferred type. Yeah.
Yeah, I was.
And this inferred thing is working right now, actually. So for me, so I getting these types.
Yeah, but instead here to nicely express the syntax for something that would be a subtype of something else, you end up with this type.
Right. You just throw in, oh, I wrote the Q. Yeah, if you just throw in a P without you don't put any type on it, it'll infer that type. Like there's no need to write the type that he infers.
Yeah, but yeah, if someone wants to enforce certain things, it will have to write a type, which would be not that great.
No, because the types are thick because they have a lot of flexibility.
Yeah.
It's because this will work for matrices. I can do the distance on a matrix, assuming that the multiplication and the addition operator do the right things at getting me, double
So
back.
that means if you rule out the precisely specifying the type, it will, if somehow you want to control, you have to do that syntactically here by manipulating these types. Maybe if you want, maybe you cast this to a double or something. You remains to manipulate the types syntactically. That's my opinion.
So I gave you the inferred type, but if you wanted to have double here instead of Q, you just put double, and that has the correct signature already.
Yeah, that would work. The whole point, if you want to write the type of this one, and with minor specific, if the things doesn't work and you have to write the whole type and you have to precisely this point to make some inflection on it so the type system can understand it. So if this is prohibitively expensive, you are resorting to manipulate that on the syntactic side to kind of adjust the types to for it correctly.
Yeah, this is one of these funny games where you're only doing this because you're restricting. If you don't bother to restrict, it never comes up.
Yeah, if you work with the point, then that's fine. So yeah. But if you work with the generic type and you, God forbid, have to specify what the type system of this generic function is, that would be cumbersome.
Given this much extra typing, I would start by breaking it up more and trying to make it pretty to look at. But yeah, you're going to get a thick, hairy type there.
Yeah, and what remains, you will avoid that, of course, and what remains, you have to manipulate that result type syntactically by inserting here some cast or some checks or something to try to avoid to write the type explicitly.
To be fair, this is also a part of library design and interface design, right? Because here you are expecting an interface which is numeric, so it's additive and it's abstractable, and it's also conformable with the square root function. So you would probably capture this family of expectations or requirements in something like a typed class numeric.
Right.
And then you would just say you have a function that takes a numeric and returns a numeric.
That's a good point. You can abstract that and write the type that explicitly. Yeah, that's a good point. Fair point.
The thing is, like, I think it's good to generally like put the I don't know, like put the type constraints, like type it out explicitly at the API boundaries, because things like whenever you have this implicit stuff, like you get the same downsides as duck typing and like C++ template errors, like because something down in a lower call can cause an error, and when it bubbles up, it doesn't make sense to the user. So I actually think like aliases, type like families, like ways to kind of aggregate stuff together. And also something I like is like the Rust impl blocks. So like when you want to define several functions, and let's say all of them have some complicated constraints on types. Then you create an impl block, which is just a scope, which has at the start just this impl keyword and then a list of types, and you can constrain them with a complicated expression or whatever. And then everything in this scope, every function that you define there is implicitly like bounded by this.
So like
this
traits.
constraint.
Yeah, it's the traits and type classes taken, but here is to Cliff is giving that ability to you to decide, do you want to go that way? If the type remains unspecified, the type system is powerful enough to infer what it means. But my concerns are what it cannot precisely enforce, because the type is so complicated. How you would enforce that? So the structural type system would give you to not specify the type and it to be inferred.
I'm confused about what you just said there. I can infer without the types, or that user adding types.
Yeah.
If the user adds a type, it will only constrain. So first I'm going to ignore your types always and just infer. Then I will look at your types, and if they don't match what I've inferred, I'll declare an error. So always type annotations are added, or user added annotations. They are always optional. You never need to add them, but you may want to because you love the documentation.
Yeah.
It could be really nice when you're developing to have a mode that's like type errors as warnings.
Well, if you just don't put type annotations in, only the type errors you get are hard fails. I cannot compile that code.
Right, but I was saying you could ignore them. So if I'm developing something and I'm fiddling with it, and I don't actually want to change all the type annotations. I just want to be like, can you just ignore the type annotations for the like 10 minutes while I'm messing with this? And then once I actually know what I want the shape to be, then I'll update the type annotations before I do a release build.
Like the Python way to quickly prototype without type system getting in your way.
Right. You want to have the types yourself. Those are your extra things. I could do that. I could just ignore the user annotations and generate code. If I can type it, I can generate code for it. If you add an annotation, that's purely a restriction. Yeah. All right, we're at noon.
I mean, I wouldn't put out a release build that had type errors in it, but.
Right. Well, I'm hoping you would use this flag. I don't know if I like flags on things. This is Simon's exact case that there's two different types. There's gradual and there's not the gradual. I've worked for a while with type system turned off. It's all compiling with inferred types. I have all these annotations. They all error out on me. Now I have a big ass job to do.
I have seen people use this even for development in dependent type languages like Agda. I have literally seen someone basically use the compiler error from the type inference to give him signature, and then she's just copy pastes the signature to the code, and it's exactly right.
Yeah, I definitely have a bijection on my type signature so that you can cut and paste them exactly, and I do that in my tests. Hey, what's this thing type as? Ooh, that's ugly. Let me copy that and throw it in the test case. And there it is. So yeah, there's a thing there.
I so often do that type of thing, and then later on I realized that while I did look at that and it seemed correct, it wasn't actually correct.
It's not, I've fallen that trap too. You're right.
It's not really a trap. You just you get notified when your assumptions were proven wrong.
Yes. Okay.
Yeah, but what Cliff says, usually if you specify something as explicit types, the compiler takes it as a source of truth and try to comply with it. But here Cliff throws you your type and synthesizes the type and check is the synthesized type is the type you specify.
Yes, I'm doing it the other way. Right.
That's the kind of bidirectional checking with the generation mode and synthesis, checking mode and synthesis mode.
Of course, you can kind of take it the other way around. So speaking of Agda, I have also seen very common practice where people only write type signatures and then just type some auto-completion and the code is inferred. This comes up, for example, when you have like pattern matching, when you have cases, when you have a type which can only be constructed from two true values like true or false. Or the option type, that the option type can be filled in or not filled in. That actually is very common, that you already have written the type. Type is the most important part of the specification. And then the code that realizes, oh, that's just trivial thing that can be inferred given the types.
That's correct. And structural typing goes kind of in between, because you let you write program without the types. So it's a trade-off.
I mean, it's kind of a good point, because if you really have types so precise that there's really only one program you can write, then why not just infer the program?
There you go.
Mhm.
Yeah, maybe.
Yeah, this is the, like, I can throw it in the docs, but like I think there was a talk about, was it Idris? So it's another also dependently typed language, and the author also does this type-driven development. Basically, you specify types with a very mathematical framework, and all the pattern matching and stuff fills out the shapes, and then you just need to check some things, fill out like some like spots, like holes in your code, and that's it. So yeah, pretty dope.
Yeah.
Right. But to some extent there, I like the redundancy. I express what I'm trying to express in the code, in the types, and in the tests. And then I expect the computer to tell me if I told it something inconsistent. And I don't know whether I got the types wrong or the code wrong or the test wrong, but I know I got one of them wrong because they didn't agree.
Yeah, right. That makes sense.
Yeah. So they're both ways. So you can specify the type and ask the compiler to synthesize the terms for it. So they're akin to the sequence calculus. That is the core of it. So from the type, you try to synthesize the terms of the program, which will match the type.
All right. I'm going to wind it down. Any last requests before I hit the done button? This has been a
I
good
had one
interview.
thing to say to Simon, like just I wrote one thing down.
Oh, in the Google Docs?
No, here locally. I just wanted to say it. Basically, at the start of the presentation, you mentioned like you building the language. Like, what is it? So there's multiple of these topics, and we can't be masters at everything. But like, I guess the question is, why do we need to be masters? Or like, you have one constraint, which is the fact that you can't be good at everything. But there's also another way that like you're constrained, namely by the ambitiousness of your goal. So like. Because some goals are actually easier to reach than others. For instance, if you only develop a language for fun, then already your complexity goes down, the amount of work you need to do. And then so like if the language is only for yourself, community management falls away. If you do something like a scripting DSL like awk, then modules, you don't need them, something like that. So I think there's also this angle. Like if you choose your goal well, if you are like thinking from the start very well about what you really want to do with your language, then lots of complexity also falls away from the other side. So that's basically it.
That's a good point. Yeah, I should.
Well, I think that goes hand in hand.
I should.
Yeah, I mean,
that
that slide
into
is
the
correct in
slides.
that sense. You're not an expert, so now pick your goals appropriately.
That's a good takeaway.
I don't see Simon using AA anytime soon.
What? You know, you can take all those keywords and just treat them like normal variables and assign them the functions you want, and then you get the keywords. You can put them in anywhere you like.
Yeah.
All right. I'm gonna claim victory and until we meet again.
Just wanted to say thank you for your patience, and if you have any further comments, just put it in the Coffee Compiler Club channel.
Yeah, your
maybe
observations
maybe
always
in
fun there.
maybe in half a year I can give you like the real polished presentation that actually makes sense instead of the thing I gave today.
If you want to have I have some generic advice for aspiring young public speakers if you want to hear it, and but not now. But yeah, we can go down.
In the chat.
Yeah. Okay.
Thank you.
Hey, next time. Bye-bye.
Goodbye.
Bye.